Now we're going to talk about compound interest again. So remember we had the formula that A of t equals P1 plus R over N to the NT, where R was your rate, P was your principal, and N was how many times you were compounding it. Okay, so this says, suppose you invest $3,000 at 5% for 8 years. Okay, so here's our function. So now we're kind of letting the number of times we compound it be our variable, N. So if you compounded it 52 times a year, so that would be once a week, after 8 years you would have $4,474.61. Okay, well what if you did it 365 times a year, so every day instead of every week? Well, it's not a huge jump, but you would have $4,475.35. Okay, you would get a little bit more. And what if you did it 1,000 times? Okay, then here, compared to once a day, almost, just under 3 times a day would only give you 8 more cents. But it does make a difference. Well, what we actually do is use compounding continuously, meaning it would be like your interest is always adding interest. And our formula for compound interest is A equals P e to the RT. And you'll notice what we don't need anymore is the N, how many times we're compounding it. Okay, so we have P is still our principal and R is still our annual interest rate. So number 2 here says, figure out the amount in the account after 8 years of continuous compounding at 5%. So how much do we start with? 3,000? Yep. So our function will be A of t equals 3,000 e to the 0.05t. Okay, and so if we want that after 8 years, that would be A of 8, plugging in 8. So we'd have 3,000 e to the 0.05 times 8. And we can do that in our calculator. So 3,000. And then we can just do our e to the x here and do 0.05 times 8 in our parentheses. So we would see compounding it continuously, if we round to the nearest cent, would give us $4,475.47. Okay, so again, not for this $3,000 and our 5% interest rate. It's nothing that you're gonna think like, oh my gosh, this is a get-rich-quick scheme. It's only a 4-cent difference, but if you think about all the investments for the bank, or if you think about if people have credit card debt and they're adding the interest, and the credit card is collecting those 4 cents difference from everybody they have, it can add up. Okay, so 3 says find the original amount invested if an account totals $19,190.98 following 9 years of continuous compounding at 3%. Okay, well let's first of all figure out what each part of this means. So we have this 19,190 and 98. Well, that right there would be the amount. Okay, 9 here is how many years. That's going to be our T. And the 3%, as we change that to a decimal, which would be 0.03, will be our R. So if we just think of our formula here, A equals P e to the RT. The amount we have is $19,190.98. The P is actually what we're trying to find. And then we have E 9 to the 0.03. Now, this may seem complicated because it's nothing you've ever done before, but it's actually very simple. We're trying to get P by itself, and we're multiplying by this E raised to the 9 times 0.03. And we're just going to divide both sides by E raised to the 9 times 0.03. Okay, so we can find out what P is in our calculator. We can do $19,190.98, and we're going to divide by E, and in the parentheses we're going to do 9 times 0.03. Okay, so if we round to the nearest cent, we'll see that $14,650 was originally invested.